everyone, I'm Mahashri Ranjith Kumar, a high school sophomore from India. First and foremost, I'm beyond glad to have you turn up at such an important event, the Youth STEM Research Conference, because you are about to learn something very, very important. Well, what is that, you may ask? It's solar panels. That's right. The clean, green, beautiful, renewable energy source that is the most sought after to reduce our reliance on non renewable energy sources such as fossil fuels. Solar installations have increased by more than 30% annually on average over the last decade, leading to cost reductions of more than 90%. So let's kick off with the basics. The three primary forms of solar panels are monocrystalline, polycrystalline, and thin film. The most crucial component of any solar panel is a solar cell. You might have heard of this as a photovoltaic or a PV cell. This converts the sunlight it receives from the sun to electricity that we use. So, most solar panels use crystalline silicon solar cells made up of silicon atoms that are connected to each other to form a crystal lattice, which you can correlate to a Rubik's Cube almost. Further, each individual solar cell is made up of two types of semiconductors. One is the P type, which stands for positive, you can relate it as P and P, and the N type, which stands for negative, N and N. The N-type silicon layer has additional electrons that move around freely, whereas the P-type silicon layer has vacancies known as holes. When the layers are brought together, the electrons begin to move from the N-type to the P-type, which forms a unique junction and generates electric potential in the material. So, when sunlight strikes this connection, what does it do? It knocks an electron loose and it leaves a hole behind. The free electrons it begins to congregate near the pole as more electrons fill in the newly formed holes. But you may ask, this is all cool. But what happens to these solar panels after their tenure of efficient working? They may last up to decades if cleaned and properly maintained, but if not, there's the catch. It goes straight to the landfills. And that's when I thought, what are we doing about this? I mean, don't get me wrong, but I found this problem after doing hefty amounts of research. And that's when it hit me. Such a major global issue, but it's barely being talked about. So, to act upon it, I wrote an article to the Science Wire. I wrote this in attempts of spreading awareness and bringing to light the importance of this ecological issue. But then I wondered, is there any potential solution to solve this problem? And that is where STEM comes in, which is science, technology, engineering, and mathematics. Solar panels can be separated back into its components, with metals such as lead, copper, gallium, cadmium, aluminum, and silicon being recovered and reused in new products. Okay, so all in all, can solar panels be recycled? The short answer is yes, it can be. So, silicon solar panels are primarily composed of glass, plastic, and aluminum. And these are three metals that are recycled in mass quantities, and materials that are recycled in mass quantities. But the problem arises. Despite the recyclability of the modules, the process in which materials are separated can be tedious and requires advanced machinery. Due to the lack of time, money, resources, and energy, an individual can only do so much. This is a global issue and must be taken in the hands of world governments and big corporations. So, the unseen side of solar panels are usually something seldom talked about, even though it's directly linked with SDG 7, affordable and clean energy. I believe it's important in spreading the word before it's too late to act upon. And as young people collectively, I hope my voice reaches you so you can create an echo. So, finally, it's important to go green. Be it solar panels, plastics, or whatever it is, it's important to know your three R's and to do the needed to save our only home, Earth. Thank you for joining in today, and I hope you could spread the word as well.